This is your Jeopardy beginning algebra review. Today's contestants are, from the 5-credit A version of the algebra class, Phyllis Jensen, a distance learning student and one of the coaches of this year's state championship football team, Oscar Jerome, returning champion and mother of two from the Tuesday-Thursday algebra class on the Germantown campus, Jan Shortall, and the host of your beginning algebra review, Bill Witte.
Welcome, players. We're going to get right to it. Remember now, today's categories, appropriately enough, are graphing, factoring, HODGE, which is a mix, equations, exponents, and everybody's favorite, word problems. Now, before we begin, let's talk to some of our players here and get to know them. Now, Phyllis, you're from that 5-credit version of beginning algebra. Is that easier or longer or harder, or how is that different than the 3-credit version?
Well, it's a bit harder. It's challenging. It's a lot of work.
So you get more time to do the same amount of work, probably, but they're both hard.
Yes.
Okay, well, that's tough. Oscar, how you doing?
Good, thanks.
Now, you're a distance learning guy.
Yes.
A lot of people think, I think anyway, that distance learning is easier. They think you don't have to take tests, or maybe there's no homework or something like that. It's all homework. Would you say it's easier or harder, or how would you say it's different?
I would say it's about the same as being in the classroom. You still have to put effort into it.
And you've done both.
I have.
So you're the fair person to say. Okay, and we have our returning champion, Jan, here. What would you say the key to your success is, Jan?
Attending class regularly and doing my homework.
Magnificent. Okay, well, you're the man. You're the woman. Okay, well, let's get right to it. Put your hands on your buzzers, and we're going to begin the game. Now, the computer has chosen Phyllis to go first, so you can pick anything on the board. It's yours, Phyllis. Go ahead.
I'll take graphing for 200.
Graphing for 200 it is. The answer is, this is the first step of any question that involves graphing. And it's you, Phyllis.
What is solve for y?
Solve for y is correct. Why do we solve for y anyway?
Allow me to demonstrate.
Well, I'll tell you. Remember, when we graph an equation, we're going to first solve for y because we have to get points.
Perhaps I could be of some assistance.
I like to make a chart like this, and that way we have a nice little formula for y. Well, how are we going to solve for y here? Who's keeping y from being alone? The 4x and the 2. So we're going to subtract 4x from both sides. That gets rid of the one on the left. And of course, 8 minus 4x, you can't subtract them because they're unlike terms. Now I've gotten rid of the 4x. I've got to get rid of the 2. Now he's multiplying, so I do the opposite. I divide. Everybody. I've got to do it to everybody. That gets rid of it on the left, and if I divide 8 by 2, I get 4, and 4x by 2, I get minus 2x. Now I've solved for y. What did that buy me?
Alrighty then.
Well, we're going to put in various numbers for x. The easiest numbers I know. I'm going to put in 0. I would marry 0. 4 minus 2 times 0 is 4 minus 0, or 4. So I have a pair here, 0, 4, that I will graph. I go over none and up 4. Okay, now I need at least one more point. I tell you to do 2 more. So what else can we put in?
Thank you, sir. May I have another?
We'll put in the number 1. Why? Because it's the easiest. Okay, now remember, I'm putting it in for x, and my formula is telling me what y is equal to. That's why I solved for y. 4 minus 2 times 1 is 4 minus 2, or y is 2 in this case. So I have the point or pair 1, 2. I go over 1 and up 2. Now I kind of already know where the line's going to be, but remember, I always tell you to check by doing 3 points. So we'll put in one more number. And we'll put in
Brain is
No, don't put in hard numbers. Put in the easiest numbers. You could put in -87, but you'd be a knucklehead. It'd be hard. Put in 2, okay? Let's see. 4 minus 2 times 2 is 4 minus 4, or 0. So we have the point 2, 0. Before we graph it, we say a little prayer in hopes that they'll line up. And son of a gun, if I go over 2 and up 0, they line up, and you know you did it because they line up. You know you're correct. Now, you're not done yet because you have to draw the line, the graph itself.
To infinity and beyond.
And there you have it. You've graphed a line. Okay? So the first step was to solve for y. Now, Phyllis, you got that answer right, so the board is yours again.
Word problems for 200, please.
Word problems for 200. This is the first step to any word problem. It's Jan.
What is x? Just find out what is x.
That is correct. We'll say we're going to define the variable. The variable doesn't have to be x, but we're going to define what the variable is, and that's correct. Let's get an example.
Not because they are easy, but because they are hard.
I think word problems are easy if you go through the steps. A lot of people think they're hard. So that's why we stress, know the steps. And as we said, the first step is to name what x is. Now let's look at this one. Kevin's age is 3 more than twice Jane's. The sum of their ages is 39. They want to know how old are Kevin and Jane. So we have to either let x be Kevin or Jane. My secret is let x equal the smaller of the two. So in this case, we're going to let x equal Jane's age. That's step 1. Can't do anything if you can't do step 1. And I cross out as I go along. Step 2 is to define everything else in x language, if you would, in terms of x. Well, who else is in this problem other than Jane? Kevin. Okay, let's start with English. Now, what is Kevin? What does it say in here? Kevin's age is 3 more than twice Jane. You're with me that you could get 3 more, 3 plus 2x. And I'm going to cross that out. Now, at this point, those are the only 2 people in this problem. If there was a Clyde, I'd have to define him in step 2, okay? But I don't have to, okay? So I know I've defined everything. It's time for step 3, and that is to write the equation from what's left. That's why I cross things out. Okay, I crossed them out, you know, to get rid of it, but I also crossed it out to see what I'm going to write the equation. And what's left here is the sum of their ages is 39. So let's see. Their sum of their ages, Jane's age, sum meaning plus Kevin's age is 39. And you've got your equation. Step 4 is to solve that equation. Well, let's see. What do we do to solve this equation? Well, we combine like terms. I'll put the 3x, or the 2x and the 1x together. And then I get x alone. I have to get rid of both of those 3's. I'm going to subtract 3 from both sides. 39 minus 3 is 36. And then I got to get rid of the other 3. He's multiplying, so I'll divide. And in this case, x is 12. But I'm not finished yet. Step 5 is to answer the question. Now, what did the question ask? How old are Kevin and Jane? I know Jane is x, because I said that in step 1. So I'll say Jane is 12. Now, what else? I got to name what Kevin is. Now, how am I going to know what Kevin is?
Perhaps I could be of some assistance.
Good thing I did step 2. Apparently, Kevin is 3 plus 2 times whatever x is. So 3 plus 2 times 12. Let's see, that computes to 27.
Excuse me!
I forgot. I have to use the units. I don't want to say 12 dogs or 12 houses. This is 12 years, so I've answered the question. Jane is 12 years old, and Kevin is 27 years old.
Oh, gnarly!
And I solved this doing the steps. Okay, so that's our look at the first step, huh? Quite a look. And let's see, who got that one right? Jan.
Equations for 200, please.
Equations for 200. This is the property used to solve quadratic equations that contain factorable expressions. Anybody? Looks like Jan. Factorable equations.
Quadratic formula?
I'm sorry, that's not correct. Anybody else? Those are for non-factorables. Anybody else? Oscar?
What is the zero property?
Very good. What is the zero property thing anyway? I forgot. Oscar didn't. Well, let's see. This is for a quadratic, so it's for an x squared type equation. We couldn't solve this by getting x alone because we have two x's, and we can't put the two x's together, so we have to have some other way. And that is, first of all, to get a 0 on one side, hence the term the zero property. Now, how are we going to get a 0 on one side? That 15's bothering me. I'll tell you what we'll do. Minus a 15, but minus a 15 to both sides now. Whatever you do to one side, you have to do to the other. Okay? That gets rid of it on the right, and then I just kind of write it on the left because they're all unlike terms. I can't combine any of them. Now, to use the zero property, I have to have 0 and I have to have multiplication. Okay? Now, to create multiplication, I'll get my buddy and I will factor. And we'll go over factoring later, but we'll factor here, and we will get quantity x minus 3 times quantity 4x plus 5. Now, you have two factors. That's why you have two answers. And what we have to look at is what makes each of these factors equal to 0. What can I put in for x? Well, in the first one, what makes x minus 3 equal to 0? 0 is not going to do it. Okay? I have to solve it. So I set it equal to 0, and I solve it. What do I have to do to get x alone here? I'm going to add a 3 to both sides. And one of the answers is 3. Now, I bet you're thinking, I could have done that in my head. And you could have, okay? But the other one, myself, I couldn't do it. I can't. 4x plus 5 equals 0. I can't do that in my head. So let me write it out and solve it. I got to get rid of two things here to get x by itself. I got to get rid of the 4, and I got to get rid of the 5. So let me get rid of that plus 5 by minusing a 5 to both sides. Now I got rid of it on the left, and 0 minus 5 is negative 5. Now I have to get rid of the 4. He's multiplying, so I divide. And that is the other answer, minus 5 over 4, or minus 5/4. So remember that a quadratic or x squared type equation has two answers. In this case, 3 and minus 5/4. We use the zero property because we could factor. And that was you, Oscar, so you have the board.
Let's go to graphing for 600.
Graphing, he skips one, okay. When 2y equals 12x minus 10, the y-intercept of this line is this value. Oscar, you're on fire.
What is 5?
5 is not correct. 5 is not correct. Anybody else? You were close. You were close. Oh, the answer is 5. I thought it was minus 5.
Pay attention, boys. I'll show you.
You're
how
right.
it's done.
You got me. Okay, so we're going to have to, what do we do first? We're going to have to, as always, solve for y. Get that 6x out of there, minus the 6x to both sides. And then, of course, we can't go 8 minus 6x because they're unlike terms. And then divide by 2. And son of a gun, in this case, the slope is the number. We didn't want to know the slope this time, but the slope is the number in front of x, minus 3, and the y-intercept is the number sitting by itself. So in this problem, the y-intercept is 4. That's not, the y-intercept isn't always the number that's first. It's the number sitting by itself. We call that the constant. Okay? Well, we're going to have to give that back to you then, Oscar. Give me another.
Let's go with graphing for 800.
Graphing for 800. This is the slope of a vertical, I'll give you a hint, up and down line. Oscar.
What is undefined or infinite?
You got them both. Very good. Now, why would that be true? Why would a vertical line have an undefined or infinite slope?
This is a pickle, George. This is a pickle.
Well, we got to consider the slope of a line is its steepness, if you would. Now, if you think about it, let's look at a line like we read from left to right. Okay, look at a couple lines just so you get the feel and remember what slope is. Now, this line here, if you were to walk on it, I hope you appreciate, we're going from left to right, you would be walking uphill. So that's going to be some positive number. We'll talk about what number that is a little bit later. This line, if you were to walk on it, well, you could go faster, couldn't you? You could actually ski on that bad boy because you'd be going downhill. I hope you appreciate from left to right.
I know that, dude.
This would be a negative slope, some negative number. Okay, now what else could we have here? As far as lines, well, we could have just a plain flat line, and walking on it, you could tell that that's flat as can be. The number associated with its steepness or slope would be 0. But that's not what we're asking here. We're asking for a vertical line. That's a vertical line. Now, if you tried to walk on that line, what would happen? You would fall, wouldn't you? And you would fall past purgatory, past hell, and whatever's past. You'd keep googing, wouldn't you? So, hence the term undefined or infinite slope, because we really don't define infinity in math. Okay? So that's the deal. A vertical line has an infinite or undefined slope. Oscar, you're the man.
Let's go with HODGE-PODGE for 200.
HODGE-PODGE. Let's see what that's going to be. The least common denominator, if you were to add fractions, with x squared y and y to the third x. It's Oscar again.
What is x squared y cubed?
You're correct. X squared y to the third is the correct answer. I think this football stuff has made you aggressive. That's great.
Allow me to demonstrate.
How are we going to find the least common denominator of two terms? Not just these two terms. The idea is to factor them, break them up as far as they can go. Okay? For instance, x squared y will break up multiplicatively into x squared and y. Now, we haven't gone as far as it can go. One of them can be broken up. X squared can be broken up into, I hope you know, x and x. So we've broken this thing up as far as it'll go into x times y. The other term, y to the third x, will break up into y to the third x. Don't be looking for something hard, because it's not here. Okay? We've got to go as far as we can go. So y to the third would be broken up into 3, wouldn't it? Y, and y. That's what people say that take this class, y, and y. Now, we're going to take those two sets, and basically we're going to do the union of them for the least common denominator. But I'm going to kind of construct it so you can see what's going on. I want to make sure that everybody's in this least common denominator. So I'm going to go one term at a time. Okay, so I'm going to construct the least common denominator. I know I need to have an x in it from this one. Actually, I know I need to have two x's, don't I? Two x's and a y. All you really have to do is write that one. Now let's go to the next term, the next set. I need a y, but I'm trying to keep this least. There's the lowest common denominator. So I already have a y, so I'm good there. Okay? But what about the other two? Well, I need him, and I need the other one. So I've covered those 3, because son of a gun, I do have 3. You can see them. Now the x, I need him, but I already have him. Okay, so don't add another one. And I think I've covered everybody. So I multiply the result, and I get x squared y to the third. Now it's important to go through and see, did you include everybody? Let's go through again. Did I include everybody in this least common denominator?
Certainly.
Is x squared y there? Son of a gun, there it is. Okay. Is y to the third x there? It is. Now there's a little bit of overlap, but good. That makes things small. Remember, I wanted it to be the least common denominator.
You're absolutely correct.
So I'm hunky-dunky. Okay, let's see what we got. It's you again, Oscar.
Let's go with graphing for 400.
Graphing for 400. This is defined by the equation y1 minus y sub 2, I should say, over x sub 1 minus x sub 2? It's Jan.
What is slope?
Very good. How could that give us slope? Where are we getting all those x and y's?
What happened?
Well, if you consider the slope is defined as the rise over run, the difference in height over the horizontal difference between any 2 points. We'll call that point 1, the point 02, and that point 2, the point 34. Okay, now where would we get the slope of that? Well, the amount you went up, you could visually see it. Okay, you could see that it's 2. Or, if you were too lazy to draw the graph, which is cumbersome to draw a graph, you could use the formula y2 minus y1. What does that mean? The y part of the second point, which is 4, and we'll subtract the y part of the first point, which is what? Which is 2. And that's what your eyes did. They saw the difference between the height of one and the height of another. And we would put that over how far we went over, the run. Now, what did you visually do there? You subtracted the x parts of the points. The x part of the second point, that's not x squared, that's x sub 2. X part of the second point, 3, minus the x part of the first point, which, what is that? That's 0. Now let's calculate, and we get 4 minus 2, which is 2, over 3 minus nothing, which is 3, and you know what? The slope is 2/3, and you could have calculated it without even drawing the picture by using that formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? Hence the need for the formula. It's Jan. The board is yours.
Equations for 600, please.
Equation for 600. This would be used to solve equations involving unfactorable expressions. Jan was all over it.
What is the quadratic formula?
Do you know the quadratic formula?
Yes, I do.
Let's hear it.
Negative b plus or minus the square root of b squared minus 4ac over 2a.
We can see why she's the champion, or the former champion. What is the quadratic formula? Now, we use the 0 property for the ones that were factorable, okay? We're going to use the quadratic formula for the ones that aren't factorable. Actually, you could use this for the ones that are factorable, too, so if you just want to remember this one. Okay? How in the heck do we use this? Now, this one's not going to be, you can factor till the cows come in, and this one's not going to work, because you can't find a number that two numbers that multiply to 3 that add up to 5. So what are we going to do? Well, we're going to look for a, b, and c. A is the number in front of the x squared. And you say, well, you don't see anything.
I know that, dude.
Now, if you don't see anything, remember, that's a 1. Okay? B is the number in front of x, and c will be the constant, the number sitting by itself. Now, we take a, b, and c and put them into this quadratic formula. It's a lot, okay? But you couldn't have done it otherwise. Well, let's see. Let's plug them in. 1 in for a, 5 in every place I see a b, and 3 every place I see a c. Okay, now we got to do some calculation. Let's get what's under the radical sign there. 5 squared minus 4 times 1 times 3. That's going to be 25 minus 12, and we're going to get 13. So I get negative 5 plus or minus, because remember, any square root has a plus or a minus, has 2 answers, okay, over 2. So I want you to consider that, and that's the answers. There are 2 answers. So consider that. We can write it as minus 5 plus radical 13 over 2, and minus 5 minus radical 13 over 2. If they ask you for an exact answer, you'll write that, the word exact. If they ask you for an approximate answer, you'll actually put that into your calculator and get a decimal approximation. Okay?
Oh, gnarly.
We could do it even though we couldn't factor. Or, if you're too lazy to write both of them, you can write negative 5 plus or minus the square root of 13 over 2. That means both answers. That's the plus or minus.
Genius. That's what it is. Sheer genius.
Show that one to your mom. Okay, Jan, The board is yours.
Hodgepodge for 400, please.
I never know what we're going to get here. This is the method whereby someone divides fractions. It's Oscar.
What is reciprocate the second fraction and then multiply?
Very good. You're on fire today. I'm going to reciprocate the second fraction and multiply. Okay, well, let's do it. Let's do it with numbers first, and then we'll show you how you're going to do it with letters or algebra. Okay? And remember, 7/8 divided by a half, we couldn't do, really. So we changed it into a problem that we could. We made it 7/8 times reciprocal. What does that mean? It means flip it. What's in the top, you put in the bottom. What's in the bottom, you put in the top. So we're going to multiply 7/8 times the reciprocal, or 2 over 1. However, before I do that multiplication, which could result, doesn't in this case, but it could result in high numbers, I'm going to cancel first rather than canceling later. I'm going to pick on these numbers while they're small, if you would. Okay, let's see. I'm looking at the 2 and the 8.
What would you do with the brain if you had one?
Well, I would cancel them. Okay, I note that 2 goes into both 2 and 8. So 2 into 2 goes once, and 2 into 8 goes 4 times, and I've made my multiplication a little easier, so I got, and that's all I can cancel. So I get the top, 7 times 1 over the bottom, 4 times 1, and that's it.
Yeah, baby. Yeah.
So that's how we would do it with numbers. How are we going to do it like we have on our exam with letters? Well, I've got some multiplication here, but I also have some division. I see the blue fraction is divided. So that is the one that I'm going to have to flip. So let's do it. We'll rewrite the problem. That'll take you about a half an hour, right? We'll rewrite the problem with just the blue portion flipped, because that's the only part that got divided. The other one, don't mix up your division and your multiplication. Multiplication, you don't flip. Okay? Now, ooh, can we cancel things that are added?
Shine, shine, shine.
Don't even, that's the most common mistake on any test. Never cancel things that are added. Okay? Canceling is division. You can't undo addition or subtraction with division. What can you undo with division is multiplication. So we've got to create multiplication here amongst those colors. You know what we're going to have to do? We're going to have to factor. We've got 6 factoring problems here. This is a good opportunity to review. Let me start with, I'm going to start with the easiest one. Okay? First step is to take out the greatest common factor. And that'll be 2. And I'm done. Okay, good thing I did the first step. Okay, now I can pick any other one I want to do. I'm looking at this one, and I would normally take out the greatest common factor of 20, but I note that negative. So I'm going to take out a negative 20, because I hate negative. Once I take it out, it's gone. And I'm looking at x squared minus 4, and I'm thinking that could go further. The second step is to look for the difference of 2 squares. X squared minus 4, I don't know if you know, factors to x plus 2, x minus 2. Okay, now we still have our work cut out for us. Let's see, who are we going to do next? Let's do him. I smell a greatest common factor here. I'm going to pull out, let's see, what goes into all 3? I'm going to pull out a 5. Okay, now I still have more to do. I can break out, I took the 5 out, I can break up x squared minus 2x minus 3 into x plus 1 and x minus 3. Okay, so I got to keep going. Who else can I do here? Oh, this is a tough one. But I smell 3x and 1x and 1 and 7. I know it's got to be 3x and 1x. How about 1 and 7? That's not going to give me the 10 in the middle. That's going to give me 21 plus 1. Let's mix them. That's going to give me 7 plus 3. That's going to give me my 10. So I'm in good shape on that one. Okay, what else? We got 2 more. Can you hang in there? This one. I know it's got to be 2x and x, and I need some numbers that multiply to 18. You know, I'm going to cheat a little bit. I'm going to look around here. Numbers about, it's either 6 and 8 or 9 and 2. Why isn't it 3 and 6? Well, that's going to give me a rainbow of 12 and 3. It's not going to give me my 13. Let me try another one.
No way.
How about mixing that, 6 and 3? That's going to give me 6 for the 2 times the 3, and 6. That's 12. That's not making it.
Oh, I can't take it
Sometimes it's hard. You got to keep trying every one. Let's see, that's going to give me 18 and 2. That's not going to work. I think that did it. Let's see, 2 times 2 is 4 plus 9. That gave me my 13. So that was a tough one. And then this last one, let's see. I need a 2x and an x, and I need numbers that multiply to 27. 9 plus 9. Actually, they need to multiply to negative 27. So I'm going to try a plus 9 and a minus 3. And that's going to, let's see, that's going to give me 9 and negative 6. That's going to work. Okay, so I've done a lot of work here. It's time to cancel. This is the fun part. I bet you're salivating. Let's try it. There's an x plus 1 in the top, multiplied, and an x plus 1 in the bottom. So I can now cancel because they're multiplied. 2x plus 9, I note, got to be in the top and the bottom. Okay, that's forming 1. Anybody else? Oh, x minus 3. And there's an x. I've got to look all over the place. Any x plus 2? There it is. Anybody else? Holy mackerel. X minus 2 and x minus 2. This is a big one. Now, numbers you can still do. 2 and negative 20 would give me a 1 and a negative 10. I divided both into, a 2 into both. And you know what? Sometimes you can cancel things that have already been canceled. For instance, 5 and the 10 and the negative 10, I can cancel those. 5 goes into 5 once, and 5 goes into negative 10. Be careful. Negative 2 times. And I'm not seeing anybody else, so let's see what's left. We've got 1 and 1 in the top. Okay, be careful. What's 1 times 1? Don't tell me 2. It's 1. Okay, and in the bottom, we have the 3x plus 7 and the minus 2. So we've got minus 2 times 3x plus 7. Now, if you want to,
I can do that, but I don't want to.
you could multiply, but you don't have to. Either one would be accepted. Okay, either one is fine. I always tell people not to multiply if you don't have to. Never do anything you don't have to do. Okay, that was quite a division problem. Remember the trick, reciprocate and multiply to divide fractions. Okay, well, let's see. It's back to you, Oscar.
Let's finish out graphing for 1,000.
Graphing for 1,000. Okay, we kind of already went over this. This is the slope of a horizontal line. It goes to Jan.
What is 0?
0 is correct. Let's take a look at this. And I'm going to prove. Now, you know that that's a slope of 0 because it's flat. But we're going to try practicing with our formula. Our what we call our point slope formula. Okay, remember that formula? y1 minus, well, y2 minus y1 over x2 minus x1. Let me prove to you that this is 0. Okay? I just put any 2 points. I could have picked any 2, and I picked easy ones at the corners. 2, 1, and 6, 1. So the second part of the y part of the second point is 1. The y part of the first point, coincidentally, is 1. Okay, so that's our rise. We didn't go up any, all right? And then remember the bottom of the formula is x2 minus x1. Well, what is it in this case? It's going to be the x part of the second point, which is 6, minus the x part of the first point, which is 2. Well, let's calculate this. Get your calculator if you need it. 1 minus 1 is 0 over 6 minus 2, which really didn't matter, did it? 6 minus, that could be a 4, 5, 6, doesn't even matter. And 0 over 4, what's 0 divided by 4?
Believe it or not.
Son of a gun, the slope is 0. We didn't even have to see this picture to know that the slope was 0, but it was nice that we did. So remember, the slope of a horizontal line, flat line, would be 0. Okay, it's to you, Jan.
Hodgepodge for 600, please.
Hodgepodge for 600. 3,100,000 written in scientific notation. Phyllis.
What is 3.1 times 10 to the 6th?
You are correct. Very good. Phyllis is right in there. 3.1 times 10 to the 6. What is this scientific notation stuff? I think I forgot that. The definition of scientific notation, of course scientists are going to use this, is to write it in the form a times 10 to the nth. Now that looks hard. What are we talking about here? A has got to be a number between 1 and 10. It's got to be an integer, by the way, a number between 1 and 10. And n has got to be the integer, okay? And then you always have 10 to some power.
Excuse me, Professor Brainiac.
So let's work backwards here. 3.1 times 10 to the 6. Remember, every time you multiply by 10, you're really moving over a digit because we're working in tens. So if I take that number, 3.1, that's where I would put the decimal. Now, where was the decimal before I put it? Any number, the decimal's at the end. We don't have to write it, but it's there. So it's after that last 0. That's where it is. And how many places is that? Well, I'll count it. 1, 2, 3, 4, 5, 6 places. So we read the number. You see? That's where it was. Now, what about this one? 7.9 times 10 to the negative 12. Remember negative exponents? Well, they're going to be very small numbers. Okay, so we're still going to go over 12 places. Okay, but we're going to go over the other direction. I hope you're not surprised that this number is a very small number. Now, where did that 12 come from? Remember, we have to have a number between 1 and 10, so we put our decimal between the 7 and the 9. That gave us 7.9. That's a number between 1 and 10. We couldn't have put it after the 9 because that would be 79, and that would be not between 1 and 10. Okay, so we got put it between the 7 and the 9. And where was it from the beginning? Well, it was way back there, and let's count our places. That's 12 places. Remember, that's where it was. Okay? Now, how are you going to know whether to put a negative exponent or a positive exponent? I don't want you to say, people say, well, I counted from the left, I'll put this, or I count from the right, I put this. I don't want you to think of it that way, okay? If it's a very, because what if you started on the right and you're supposed to start on the left, or if you started on the left and you're supposed to start on the right? I want you to remember, if it's a very large number, the 10 should have a positive exponent.
I'm dangerous. I'm very, very dangerous.
And if it's a very small number, basically a decimal number, the size of an electron or something, 0.0000 something, it should be a negative exponent. So large numbers have positive 10 exponents. Small numbers have negative exponents. Don't be working left to right or right to left. Okay? Let's see. We're back to you, Phyllis. You're bored.
Take exponents for 200.
Exponents for 200. This is the value of anything, any base, to the 0 power. It's Oscar.
What is 1?
1 is correct. How could that be? How could something to the 0 power? What do a lot of people want to think this is? They want to think it's 0. Okay? Well, here we have 5 to the 2 times 5 to the 0. Let's consider that if whatever this to the 0 power is, if it is an exponent, it's got to follow all the rules of exponents. Okay? And what does the rule of exponent have me do in this case? Well, 5 to the 2th times 5 to the 0th, I hope you remember that in this case you're supposed to add exponents. So this would equal 5 to the 2th. Big deal. What does that have to do with this 0 thing? Let's try and get back to that. Well, think about it. What would you have to multiply 5 to the 2th by to get 5 to the 2th? In English, if you would. What would I have to multiply that by? Well, what does this have to be? There's no getting around it.
Stranger from the outside.
This is not a stranger. You're used to when you multiply something and get the same thing, there's only one number that does that.
So let it be done.
And that's your buddy 1. Okay? So if you think about it,
So let it be written.
anything raised to the 0 power has got to be 1. I say anything, not just 5. Okay? Because these two animals have to be the same thing. Otherwise, it's not going to work. All the rules have to work. There's no exceptions here. So x to the 0, 7 to the 0, anything to the 0 power, we're going to remember, is 1. Okay, that's tricky. Not 0, it's 1. And it's Phyllis. No, I'm sorry, it's Oscar. Oscar, to you.
Let's go with word problems for 400.
Ooh, word problems for 400. The word of in a word problem generally is interpreted as this operation. Phyllis.
What is multiplication?
Very good. It is multiplication. Where in the heck are we getting that? Well, if you think about it, I always use the example, if I said, if you have 3 of those cartons, you know 3 of those cartons that have a dozen eggs in them, how many eggs do you have? 3 of 12. Of course, you all know what you do. You multiply 3 times 12. Okay? So, just remember, of means times, 99.9% of the time. Okay? It's back to you, Phyllis.
Factoring for 200.
Factoring for 200. This is divided out in the first step of any expression. It's Oscar.
What is the greatest common factor?
You are correct, sir. The greatest common factor.
Now look at, I say look at here.
Remember your factoring checklist. First thing you're going to do always, even though you might not be able to, is to factor out the greatest common factor. Then we look to see to do the rainbow trick. And if you can't do the rainbow trick, in this class anyway, we can't do it. Okay, you stop there. Okay, let's take a look at an example. It's been a while, hasn't it, factoring? We have to look for the greatest common factor. Now I'm looking at this and I'm looking at all 3 and I'm saying, what goes into all 3? As far as the numbers,
It always best to start at the beginning.
let's see, factoring out the greatest common factor.
Are you pondering what I'm pondering?
I'm thinking 2x squared. But you know what? I'm thinking wrong, because I'm looking at the 3 and I'm seeing a 2 goes into all of them and x squared goes into all of them. But it would be easier for me, I hate negatives, especially when that first one's negative, not to take out 2x squared, but rather, let's take out negative 2x squared, because once you take it out, it's gone. And I hate negatives, and we'll get rid of him early. So let's bring him down and divide through. Divide by negative 2x squared. There, I get a positive. You love that. You would kiss that. Divide him, got to do it to everybody, that's why it had to go into everybody. Divide him by negative 2x squared, and that gets a negative. That's okay, because that's the second one. I'm just worried about the first one. And we'll divide him by negative 2x squared, and we're looking good so far, we think.
I can do that, but I don't want to.
Well, let's check it. Let's make sure. This times this, does it equal? Yes, it does equal negative 6x to the 4th. We multiply here. Let's see, negative 2 times negative 8. We do get the positive 16x to the 3rd. And negative times negative, I do get 22x squared. So we're looking good there.
The important thing is, isn't your final answer?
But we're not done yet, because the blue part can go a little bit further. What can we do? Bring that down, and let's break it up using our rainbow trick. We know these two always have to multiply to the first term, 3x squared. So that wraps that up. That's 3x and x. And these two have got to multiply to a negative 11. And that looks pretty good. Let's check the rainbow. Rainbow is the outsides, which will give me a negative 3, and the insides, which will give me a plus 11. What does that add up to? Oh, it didn't work. I need that negative 8. It didn't work. So we're close. We're close. I say we keep the same numbers but switch the signs. Let's do that. 3x and x, and minus 11 and plus 1. Okay, now let's check it though. You're never sure. Do the outsides and the insides. That's going to give me a plus 3 and a minus 11. Plus 3 on the outsides and minus 11. We got it. We know we're right. That's what I like about those. If you check it, you know you're right. Okay, so there it is. That's the steps of factoring. Okay, well, let's see. we're in Oscar again.
Let's go to word problems for 600.
Word problems for 600. This is the final step to any word problem. It is Phyllis.
What is the answer? What is answer the question?
Very good. You had to say that. Answer the question. Okay, what do you mean answer the question?
Excuse me, Professor Brainiac.
These word problems can be tough if you don't know the steps. Here we got a 14-foot hose is to be cut into 2 pieces so that the longer piece is 2 feet more, 2 feet more than 3 times the shorter piece. Let's find the length of each piece. Okay. First thing, name what x is. Well, we have a smaller piece and a longer piece. I'm going to always let it equal the smaller. I'm going to let x equal the shorter piece. And that means in step 2, what else is involved in this problem? Well, the longer piece. In English, now we have to figure out what it is. Well, it says 2 feet more than 3 times the shorter. Oh, 2 feet more than 2 times the shorter, I'm sorry. So 2 feet more is plus, 2 times the shorter is multiplication. And we've got both. Let's cross out what we've done. And if there was a third piece, I'd have to define him in step 2, but there isn't. So it's time to write the equation from what's left. We've got a 14-foot hose in 2 pieces. So I've got the longer piece plus the shorter piece. What's the shorter piece? X. And that's supposed to equal 14. So I've got an equation. That's it, from what's left. Let's solve that bad boy. Combining like terms, 2x and 1x, I get 3x. Now let's get x by itself. Make sure you do it to both sides. That's a common mistake. Minus 2 to both sides, and divide by 3. And x will equal 4. But did we answer the question? What is the 4? How did I know that 4 was the shorter piece? Well, good thing I said that up here in step 1. Okay? I still haven't answered the question. What is the longer piece?
The important thing is, isn't your final answer?
Oh, how am I going to figure that out? I'll have to use what I wrote in step 2. The longer piece is 2 plus 2 times whatever x is. 2 plus 2 times 4, or 2 plus 8. So your answer's... On this exam, I have to take a point off if you don't write the unit. Okay, so make sure you use the unit. Okay? And it went in as feet, so it comes out as feet. So there's your answer. Okay, good show, Phyllis. It's all you.
I'll take factoring for 400.
Factoring for 400. There are 2 things required before we use the zero property. Oscar.
What are 0 and multiplication?
Very good. You need both. Remember this one? The zero property. It's going to be all over the place. The zero property states that if 2 numbers, A and B, multiply to 0, what has to be true if 2 numbers multiply to 0? One of them has to be 0. That's as easy as that is. That's the zero property. Well, let's think about it. To use the zero property, what do we have to have? Okay, as stupid as that may seem, we have to have 0. Okay, it's not like this is the 12 property or something, or the 75 or 11-12 property. You have to have 0, and we have to have multiplication. Okay, you have to have both, or it doesn't work. Okay.
Now look at, I say look at.
Here's an example. Okay, we have to have 0, so let's get a 0 by adding 12 to both sides in this equation. And then we have to have multiplication, which we don't. What creates multiplication is factoring. Okay, so we'll factor here. You've got to be a mean, lean factoring machine. And then we take each of these and say,
Show me the money!
what would it take for each of them to be a 0? What do I put in? I can only change x. Okay? Taking a look at this part of it or this part of it separately. Okay? What is it going to take to make them multiply to 0? This is the zero property. Either the first one or the second one has to be 0. So what I can do is take what it makes them equal to 0. One of them is -3, and the other one is -4. That's what I have to put in. And that's my answer. So remember, to solve using the zero property, we're going to get a 0 on one side, then we're going to factor, then we're going to figure out what x needs to be to make each of the factors be 0. Okay, Dee? Okay, well, let's see. It's you, Oscar.
Let's go to exponents for 400, please.
Exponents for 400. Okay, it's a tough one. X to the third, x to the fourth squared. Oscar?
What is x14?
Let's see. That is correct. How in dog lips did we get that? Okay, well, let's see. I think we're going to do what's in parentheses first. Remember that x to the third really means x times x times x. And x to the fourth really means 4 of them. Okay? Now, the squared means he has power over both of them, everything in parentheses. So we're going to have to write everything how many times?
Making copies.
Twice. Okay, now it's a matter of copying. Okay, how many, or a matter of counting. Okay, now there's a shortcut. You could have added the parentheses, added the 3 and the 4, and then multiplied. Those are the shortcuts. But if you don't, if you get nervous on your exam, heck with it. Okay, just write them out. Okay, remember the 2 rules. If you want the shortcut, x to the a times x to the b is x to the a plus b. That's when there aren't any parentheses. And x to the a to the b
I know that, dude.
is when there are parentheses. So we really had 2 rules in that. That's a good exam question. Okay? Okay, Oscar, you are the man. What do you got?
Let's go with equations for 400.
Equations for 400. The trick used to solve any equation that contains fractions. A very useful one. It's Oscar.
What is reciprocate?
I'm sorry, that's not correct. The answer is to multiply through by the least common denominator of all the fractions.
Holy alphabet.
For instance, in this equation, the least common denominator, I'm only looking at bottoms, okay, the 5y, the 7, and the y. The least common denominator
Now I use my secret weapon.
is going to be
LCD, man.
35. Okay, now what's he going to buy me if I multiply everybody by 35y? Well, everything's going to cancel. I want to get rid of these fractions. I hate fractions. Okay, 35y divided by 5y is 7. 7 times 6 is 42. 35y divided by 7, all these nicely go in because it's the least common denominator. It's going to be 5y. And you multiply what's left, you get 5y times 2, 10y. And then on the other side, the y's cancel, and 3 times 35.
You look marvelous.
Now, I love the looks of this because there's no fractions. All I have to do, my mother can solve this one. Subtract 42 from both sides. I got to get y by itself. I'm going to get rid of the 42 and the 10. So I subtract 42 from both sides, and then divide by 10. 10's multiplying, so I divide. 63 divided by 10 is 6.3.
Hey, this is great, man.
So that's a nice trick when you have fractions. Multiply through by the least common denominator.
You just want to be?
And you got yourself an answer. Okay? Okay, let's see. It's back to Oscar.
Let's go with exponents for 600.
Exponents for 600. This is the trick to changing a negative exponent into a positive exponent. Oscar?
What is reciprocate?
That's it. You were remembering something there. We reciprocate. Well, when you see this, you're scared. Okay? We're scared on this one. Let's see. Reciprocating. Reciprocate means if it's in the top, put it in the bottom, and if it's in the bottom, put it in the top. So we're going to take this one, because he's negative, and put him in the bottom, and he'll become positive. And we'll do it one at a time. The z to the minus 7, he's in the top, so we want him to become positive, so we'll put him in the bottom. Okay? Now what else do we have left? What haven't we done? The x to the 6, now wait a minute. X to the 6 is not negative. So we're not going to do that. We just leave him there. And z to the minus 2, he's in the bottom, so reciprocating, he goes in the top. Well, now I'm hoping you would know how to do it. What are we going to do? These two guys are on the same side, so they get together. These two guys are on different sides, so they're going to cancel each other out somewhat. And we're going to have to subtract exponents, and the answer is going to go where the biggest one was. Now remember, you have to have a top. You girls remember that. Don't be running around without a top on. So we're going to put a 1. You have to have a 1. You don't have to have a bottom, but you have to have a top. And that, in this case, will be your answer. So the trick is to reciprocate, okay, on negative exponents only. Okay, Oscar, what do you got?
Let's try factoring for 600.
Factoring for 600? X squared minus 16 completely factored. It's Jan.
What is x plus 4, x minus 4?
Very good. How did we get that?
There's something screwy around
We're used to
here.
having 3 of them, aren't we? Well, the middle one is there. We just don't write it because it's 0. You don't write 0. Okay? Now, once again, we're back to the rainbow trick where we're looking for numbers. First ones always give me that x squared, and the last ones always give me 16. Now, this isn't a good guess because the rainbow won't give me 0. I need to get 0. In this case, it's not happening. How would I get 0? Well, I need 2 numbers that both multiply to negative 16 and add up to 0. I know I need the x and the x. I think it's going to be plus and minus of 4. And son of a gun, if you think about it, minus 4 and plus 4, there's your boy. And that's what you wanted. Even though you didn't see it, you got your nothing. Okay? So that's sometimes we call that the difference of 2 squares.
Excellent.
Okay? So it's looking like we're just about out of time now. Okay? Let's review the scores here. We've got, oh, this is a close one. We've got Jan in the front with 2,600. Oscar just in second with 2,400, and very closely following is Phyllis with 1,800. This is quite a game, okay? But we'll have to stop for this time. Make sure you tune in next time to see who wins, okay? I'm Professor Bill Witte. We'll see you next time.